Okay, so we're going to look at the last part of section 2.2 today. So as long as we get through everything, we should be able to finish the material for the week today, and then tomorrow will be review day. So yesterday we looked at finding the 6 trig functions, the sine, the cosine, tangent, the cosecant, secant, and the cotangent of 3 angles, 30, 45, and 60. Well, 30, 45, and 60 are basically always in this quadrant. Okay, so yesterday we just stayed in quadrant 1. What we're going to look at today is doing multiples of those angles. So that means we could end up in quadrants 2, 3, or 4. The nice thing is all the coordinates that we know, the root 2 over 2, root 2 over 2 for 45, and then the 1/2 and root 3 over 2 for the 30 and the 60, you use those same numbers. Okay? So we don't have to learn any new coordinates. The only thing that happens is, let's say that, I don't know if I drew this yesterday. Let's say you had 45 degrees right there. Okay? And you make a triangle just like we did yesterday. That's 90. That's 180. Let's look at 45 degrees in quadrant 2. So to get there, you'd have to add 45 to 90. So what's 90 plus 45? 135. So if we put a dot right on 135, and I make a triangle, how does that compare to the triangle that I just made in quadrant 1? Yeah.
Like a mirror?
Yeah, it's a mirror image. So the lengths of the sides are still the same. They're both square root 2 over 2. It's just when we write the coordinate, we have to take into account the direction that we went. We went left and up instead of right and up. So if you go left, what kind of number is the x value if you go left? Joe? Negative. So it's negative root 2 over 2, but we still went up. Root 2 over 2. That's going to be the only difference with the coordinates today. Sometimes there'll be a negative in front of x, sometimes a negative in front of y, sometimes a negative in front of both, depending on the quadrant. But you're still going to use root 2 over 2, still going to use a half, you're still going to use root 3 over 2. Okay? Any questions on that idea? We'll go through a 45-degree angle in each quadrant just to practice it. Also, since we've done a lot with all 6 trig functions, I might start out with one where we do all 6, but then after that, I might just ask for one, like just the cosecant, just the sine, just the cosine. That's more how the test is going to be set up. Okay, just one per problem. Alright, so that's what I already told you. You're still using the 30, 60, 90 and the 45, 45, 90 from yesterday. We're just in different quadrants. So we don't need to go over that again. Okay, so let's try the 135, the one we actually just drew. Yeah.
So why do we need calculus if we just flip it to the negative? Or 1 or 2 and then it's negative?
So eventually we're going to do ones that are not multiples of 30 and 45. Like I might ask you, what's the sine of 127? So because that's not a multiple of 30 and it's not a multiple of 45, we don't have a triangle to draw for it. So then we'd have to use a calculator. Okay, so 135, I kind of went through it already. So 90 is up here, 180 is over here. 135, that's exactly halfway between 90 and 180. If it ends in a 5, for the angles that we're dealing with, it's a multiple of 45. Okay, if we're talking about the circle. I'm not saying every number that ends in a 5 is a multiple of 45, like 55 isn't. But the numbers you're going to see are 135, 225, and 315. Okay, so if we're talking about an angle that ends in a 5, and we're doing it on this circle, it's a multiple of 45. And that's the first thing you have to figure out. Is this number a multiple of 30 or 45? If it's a multiple of 30, then I'm going to be using the 1/2 and the root 3 over 2. If it's a multiple of 45, what's the fraction that I use for that one? Square root of 2 over 2. So that's how I'm going to decide which triangle I'm using. Is it a multiple of 30 or 45? Yep, just sign off. Okay. So the way you draw your triangle, always draw the hypotenuse to the origin. And then draw the other leg perpendicular to the x-axis. Okay. So now, earlier I had asked somebody, what's 45 degrees past 90? That's this part right here. That's 135. Okay, that's 45 degrees. So that means this is 45 degrees. Okay, those two things have to match up. Now, if the angle on the outside is 45, how much is the one on the inside?
45.
Yeah, it's got to be 45 because the quadrant makes a 90. So that's why you have a 45 there. And then if you have a 90 and a 45, the top one's got to be 45 too. So there's your 45, 45, 90 right triangle. Both sides are root 2 over 2. When you write the coordinate though, make sure you take into account the direction. If you go left, you got to put a negative. If you go down, you got to put a negative. Right, so the coordinate, negative root 2 over 2, because we went left. And then positive root 2 over 2, because we go up. Other than that negative, everything else is exactly the same as what we did yesterday. Any questions on how we got that coordinate? Okay, so let's go through all 6 trig functions. Okay, see, I'll see if I can keep the coordinate. Yeah, I can keep that on the board at the same time. All right, so let's start with the sine. And now this is going to make a difference which one is x and which one is y, because if you mix them up, they're not the same. One's x, well, one's negative, one's positive, so you can't mix them up the same. So K, what would be our sine?
Root 2 over 2.
Yes, the y value, which is root 2 over 2. Okay, I'm Christian, my cosine.
Wouldn't that be negative root 2 over 2?
Yep, negative root 2 over 2. And my tangent is when I take y and I divide by x. Y and x are the same, except one's positive and one's negative. So it's like you're dividing two numbers that are opposite. So what would you get in that case?
Would be negative?
Negative 1. Yep, because you got a positive divided by a negative, and they're the same number. So negative 1. So while we're down here, let's do the cotangent. If the tangent is negative 1, what's the cotangent? Yep.
1. On this side.
So what, if you made that a fraction, what number is in the bottom? 1. And if you flip it, you have 1 over negative 1. What's 1 over negative 1, Eric?
Is it positive 1?
Negative 1.
So a positive divided by a negative always gives me a negative. So that the answer there would be negative 1. Yeah. Any question on that? Okay, so negative 1. Now the other ones, we've got to be a little careful because when we flip it, the root goes to the bottom. So Savannah, what do I get when I, my first step to get the cosecant, when I just flip the sign?
You'll get 2 over the square root of 2.
Yep, so I get 2 over the square root of 2. And then, does anybody remember what you get when you fix that and make it multiply top and bottom by the square root?
Square root of 2.
Just the square root of 2. We've gone through that kind of thing a couple times, and that's what you get. Now, if the cosecant is the square root of 2, what's the secant?
Would be negative square root of 2.
It's just negative square root of 2, because the only difference when you flip the cosine is it has a negative. The sine didn't. So that's the only difference in the final answer. It has a negative. And that would be your 6 answers, working with 135. Any questions on that? right, so that's a 45-degree angle in the second quadrant. Let's look at this one. This time they only want to know one thing, just the cosecant. Okay, you don't have to find all 6. Okay, so that's cosecant of pi over 4 radians. Does anybody remember what pi over 4 would be in degrees?
45.
How much?
45.
45, yeah, it is a 45. If you're not sure, you could always change it to degrees by multiplying by 180 and divide by pi. Any questions on how to change pi over 4 to degrees? Okay, so we know it's a 45, so we're going to put it over here. I really only draw the triangle if I don't know the coordinate. I already know the coordinate for 45, but I'll practice drawing it just in case anyone needs to see it. Okay, I didn't ask the question, but 45 is a multiple of 45. Okay, 45 is not a multiple of 30. That's why I'm using the root 2 over 2. Okay, so what's my coordinate for 45 degrees? So square root 2 over 2, comma, square root 2 over 2. And now they want the cosecant, which is which letter flipped? Even though this time it wouldn't make a difference, you should know. Yeah, it's the y flipped. So you take root 2 over 2 and you flip it. And we just did this in the last problem. When you fix it, what's your final answer? Yep.
2.
Careful, not 2, Eric.
Square root of 2.
Square root of 2. Yep. So we're close. Okay. Any question on that one? And that's it. That's the only thing you have to find. So on the test, I'd look for 2 things. Did you give me the right coordinate? Did you give me the right answer? All right, let's try 225. All right, so we should kind of have an idea of where that's going to be. We know it's halfway between 180, well, it's between 180 and 270. But is it closer to 180? Is it going to be closer to 270? Or is it going to be right in the middle?
In the middle.
Yeah, 225 is a multiple of 45, because it ends in a 5. And it's right halfway between the two. If you take 180 and add 45, you get 225. If you take 270 and subtract 45, you get 225. It's right in the middle. So let's make our triangle. All right, so I've got a triangle. And since it's a multiple of 45, I should know the lengths of each of the sides of that triangle. How long is each side? Yep.
-2, 2 squared over 2, and then -2 squared over 2.
Well, first let's just deal with just the length of it. Don't worry about the direction yet. When we write the coordinate, we'll worry about the direction. For now, I just want to label how long the sides are. So Derek, can you tell me how long they are?
Square root of 2 over 2.
Square root of 2 over 2. And then the other one?
Square root of 2 over 2.
Yes, they're both square root of 2 over 2. And now we're going to do what Joe was saying, is we're going to put in the direction. And Joe, on both of them, they're going to be what kind of numbers?
Negatives.
Yep, they're both negatives. So negative root 2 over 2. Negative root 2 over 2. And now the last part is just the sign. So Oscar, what would the sign be?
It'd just be root 2 over 2.
Yeah, and because they're the same, can you just tell me which one you picked?
The y.
The y, yes. And that's the answer. Any questions on that one? Okay, so we've done a 45-degree angle in quadrants 1, 2, and 3. Let's try this one. Cosine of 7 pi over 4. Now, that's one you might not recognize right away in your head. So, Mike, if I don't recognize what 7 pi over 4 is, how can I change it to degrees?
180 over pi.
Yep. Multiply by 180 over pi. Pi's cancel. 4 goes into itself once. And 4 goes into 180 45 times. And all I'm left with is 7 times 45. Okay, so if we do that out, what do we get? What's 7 times 45?
315.
315. So finding the cosine of 7 pi over 4 is the same thing as finding the cosine of 315. Okay, so we have 270. And that's 0, but it's the same as 360 if you go all the way around. Where's 315? Closer to 270? Closer to 360? Right in the middle. Yep, it's right in the middle. 315 is 45 degrees away from both of those numbers. So make our triangle. Label it. It's a 45, 45, 90. Label the sides. How about, Justin, how long is each side here?
Square root of 2.
Yep. Over 2. Square root of 2 over 2. Now we got to make sure we take into account the direction. We went right and we went down. Right, so Joe, can you tell me what my coordinate would be, taking that into account?
Square root of 2 over 2, negative square root of 2.
Yep. So there's your coordinate. Now we got to look at what they want. They want the cosine. So Kay, what would be the cosine of 7 pi over 4 using that coordinate?
It'd be the square root of.
Yep, the x value, which is positive square root of 2 over 2. Any questions on that? Okay, so at this point, what you should know is you should be able to find the coordinate for any of the 4 points I just marked. Those are all the 1s and 0s and negative 1s. And you should be able to find the coordinates for all the 45s. Okay? We just went through each one of them. Now we're going to take a look at the 30s and the 60s. Those are the 2 points that are on each side of the 45s. So now that the black ones are going to involve the 1/2 root 3 over 2. So by the time we're done, there's 16 different points on the circle I can ask you about. Right?
That's a lot to memorize.
You need to really memorize like 3 of them.
Yeah.
You only have to memorize 3 numbers because every other number is the same, just with a negative in front. So if you're trying to memorize like brute force, every single one of these, and keep in mind I can ask you for the sine or the cosine or the tangent, the secant, the cosecant, or the cotangent for any one of those dots. So that's a possible 16 different dots times 6 questions per dot. So there's 96 basically different questions I could ask. We've done a lot of them this week. If you try to memorize all 96 answers, you're going to go crazy. It's way too much. Just memorize those 3 numbers. Root 2 over 2, root 3 over 2, 1/2. And then you can figure out anything you need to from there. Right? Like if you said to me really off the top of my head, what's the secant of 330? I could do it in my head. I can't tell you the answer, like I don't have it memorized. But I can figure it out in 10 or 12 seconds. Just picture the circle, get the coordinate, and go from there. Okay. But yeah, don't try to memorize it. That's too much. Okay, so let's try tangent 120. Okay, again, off the top of my head, I'm not sure. But I know how to make the triangle, and from there I can label the sides, and then from there I can get the coordinate. Those are the steps I would go through in my head if someone asked me that question. So I picture the circle. I've got 180. I've got 90. Now I try to picture where 120 is. I have 3 options. Is it right in the middle? Is it closer to 180? Or is it closer to 90? It's closer to 90. So it's right like that. Make my triangle. Since it's closer to 1 than the other, it's not right in the middle, this is not the 45, 45, 90. Another way to figure that out is look at the number 120. Does 45 divide into 120?
No.
No. Does 30 go into 120? Yep. This is the 30. This problem has to do with the 30, 60, 90 triangle. So we've got two sides. We've got the short side right there, and we've got the long side right there. In this triangle, the short side is always how long? 1/2. Yep. And the long side is always?
Square root of 3.
It's always square root 3/2. And now, write your coordinate, just like we did, but make sure you take into account you went left and then up. So what would be my coordinate for 120 degrees? Negative. Well, we got to use these two numbers.
Negative square root of 3 over 2.
Well, square root of 3/2 is up, so that's positive.
So, but wouldn't that be fair since it's 30? No, yeah.
So square root of 3/2 is up. That one's positive.
So it'd be square root of 3 over 2 and then negative 1/2.
Make sure we put them in the right order, though. One's x and one's y.
I thought 60 had the 1/2 first, though.
Well, this is 120. When you have 60, you're over here. It's a mirror image of that triangle. That's 60 right there.
Yeah, but I was just thinking it was the same because like the other side is for 60 and 30.
It is the same as the 60, but the 60 has the 1/2 first.
Mm-hmm. Yeah, that's what I meant.
Yeah. Yep.
That's why I was saying the other one first.
So it's the same as the 60, it's just a mirror image. So what are we going to put for the x? Negative 1/2. And the y? Square root 3/2. If you take away the negative, now you've got the 60. Right? But it's just the same thing. Okay, and now they want the tangent. Christian, what's my formula for tangent?
Isn't it y over x?
Y divided by x. And what's going to happen there? Yeah. 2's are going to cancel. Same thing that keeps happening all week. 2's cancel, and I'm left with square root of 3 divided by negative 1, which we can just write negative square root of 3. Okay. Any questions on how we got the coordinate or how we got the negative square root of 3? Okay, let's try this one. The secant of 690. Now, first thing I do is I look at that and I'm thinking I should do something to that angle. What should I do to it? Yep, you always want to make it as small as you can, but not too small where you make it negative. So if you subtract 360 one time, you get 330.
If you do that, doesn't matter what, it'll like come out the same.
Yep. As far as trig, 690 and 330 are the same number. Yep. Okay, so 330. Well, I know this is 270. I know that's 360. So now I go through all the questions in my head. Is 330 right in the middle? Closer to 270? Closer to 360?
360.
It's closer to 360. So I'm going to put the dot closer to 360. The only reason I graph it is so then I can see in my head where's the short side, where is the long side. That tells me where the 1/2 is and where the root 3/2 is. Okay, so here's my long side. Long side is always what number? Always square root 3/2. And the short side?
1/2.
That's always my 1/2. Okay, so now let's write our coordinate. Just make sure we take into account we went down. Yep, Chris?
Would it be Negative, no, my bad. Square root of 3 over 2.
Yep.
Negative 1 half.
Square root of 3 over 2, negative a half. Okay, so there's my coordinate. And now they want secant. So secant is when you flip which one? The x. So you get 2 over the square root of 3. And when you fix it, what will you get?
2 square root of 3 over 3.
2 square root of 3 over 3. And there's the secant of 690. Okay, any questions on that? How many more? I got a bunch of them. We can do one with a negative. Do people want to see one with a negative? Okay. So we've got negative 7 pi over 6. I would change it to degrees first. To change to degrees, how do I do it?
Times 180.
Times 180
Over pi.
over pi. Pi's cancel. I'm not even going to reduce it because I'm just going to type it all into the calculator. I know I can divide 6 into 180. Don't worry about it. So negative 7 times 180 divided by 6. I get negative 210. What do I want to do with negative 210? Yeah. Add 360. So I'm working with a 150 degree angle. Okay, so 150. Now I'm trying to picture where that's going to be. 180, 90. In the middle, closer to 90, closer to 180. Closer to 180. So that means my triangle is laying down on the long side this time. It's not standing up on the short side. Long side, 3 over 2. Short side, 1 half. So what's my coordinate for 150?
Negative square root of 3 over 2.
Yep. Negative square root of 3 over 2. Up a half, so I get the coordinate. Cosecant is when you, bless you. Cosecant is when you flip which one? Flip the y. When you flip 1 over 2, you get 2 over 1, which is just 2. Okay, any question on that? So I'm going to put up the chart that shows you every angle at the same time. It looks a little confusing because they draw every triangle that you can have in every quadrant at the same time. But I'm just trying to show it to you so you can see the patterns, which I think we already kind of see anyway. So if you look at the 45s, root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. They're all root 2 over 2. It's just sometimes there's a negative in front of one or both of them. The green triangles, those are all root 3 over 2, 1 half, root 3 over 2, 1 half, and so on. The only difference is sometimes there's a negative in front of one or both. And then the blue triangles, those are your 1 half root 3 over 2s. Sometimes there's a negative in front of one or both. The purple dots, that's what we did the first day. Those are all the zeros and ones. Okay. So if you can basically just remember what I just circled, if you can remember those 3, then you automatically know all the other ones. Okay? And you also have to remember the 1, 0, 0, 1. Okay? But those are easy because there's no square roots. And as far as trying to remember 5 pi over 6 is 150 degrees, you don't have to remember that. You can always just off to the side, multiply by 180, divide by pi, type it in on your calculator and figure it out. So you don't even have to memorize the angles. You can always figure it out by hand. It's slower to figure it out by hand. If you memorize it, it's faster, but you don't have to. Okay. So that's unit circle trig. Any questions on that? Okay, I didn't practice every single answer to every single angle because there's 96 different possible questions. And that doesn't even include giving you angles to add and subtract 360. If you include doing that, then there's an infinite number of questions. But 96 basic questions. 16 angles, 6 questions per angle. You'll have about 12 or 13 questions on the test. All right, so we're going to take a look at kind of doing the same thing, except we're going to look at what happens if we don't have a point on a unit circle. Luckily, it's really not that much different. Everything kind of stays the same as far as the formulas. So there's one small thing that will change. So let's pretend that this circle is the unit circle. 1 unit in every direction. That bigger circle, well, it's not a unit circle. How big is it? We don't know. It's bigger than the unit circle. So if I was doing a problem on the unit circle, I would have something like that. I would put a point, make my triangle, and figure out the coordinate, and then go from there. Well, on this bigger circle, I do the same thing. Put my point, figure out the coordinate, and go through the same thing. The difference is, look at the radius of the green triangle. It's not 1. Okay, it's bigger than 1. So the goal is to basically figure out how we can make this problem using the red triangle. Okay, we don't want to use the green triangle. Right, that's on a bigger circle. Maybe that's a circle of radius 5 or 6, 7. It's bigger than 1. But if we can somehow turn the green triangle, kind of shrink it down enough so that it becomes the red triangle, then we can do the problem like we used to. So we got to think about kind of shrinking that green triangle down. That's kind of the idea. So let's pretend that, just for a second, that the radius of the green triangle was 5. The radius of the unit circle is how much? 1. So what could you multiply 5 by to make it 1? Kind of think of this as you're scaling the triangle down. You'd scale it down by how much? 1/5. So if you take 5 times a fifth, you get 1. Let's pretend that the radius here was 8. And I asked you, what would you have to scale the green triangle down by to make it exactly the same size as the red triangle? Because the red triangle we know how to do. The green one is too big. What would you scale the green triangle down by? Yeah. 1/8. Alright. Now, let's say the green triangle had a radius of r. Any radius. What would you scale the green triangle down by now? So that when you do that, it would come out to the same size as the red triangle, which is what we already know how to do. Yep.
R over 1. Or, yeah, no, it would be R over R or something. It's gonna equal 1.
Well, when it was 5, we did 1 over 5. When it was 8, we did 1 over 8.
So it's 1 over R.
So it's 1 over r. And that's the whole key. If you take and divide each side by r, it takes the green triangle and turns it into the red triangle, which is a problem we know how to do. So that's the whole key. You divide everything by r. So let's look at what happens when we do that. So before, the sine was which letter?
Y.
Y. And what did I just say to do to every letter? Divide them by r. So what do you think the sine would be if you had the green triangle? It was bigger. It wouldn't just be y, it would be, yeah,
Y over R.
it would become y over r. If you take everything and divide it by r, that gives you what we call the general formulas to do trigonometry on a circle. Any circle. Up until now, I've only given you a unit circle. But you can do it on a circle with radius 2, radius 6, radius 15, anything you want.
Okay, so like, if we're trying to get what we're trying to get right now, that's how we're going to write out every one.
Yep. Yep. And I'll show you an example in 1 second. So sine was y, and we said the whole trick was right here. Multiply everything by 1 over r. Well, that just means divide everything by r. So y gets divided by r, x gets divided by r. Wait a minute. Tangent. What did we have for tangent before?
Y over x.
Y over x, it didn't change. Well, that's because if you had that before, and you change y to what we just did, change y to y over r, change x to x over r, what happens when you divide there?
The r's just cancel.
The r's just cancel out, and you're left with exactly what you started. So that's why tangent doesn't change. Now, what do you think we're going to do with each of those to get those? Flip. So the cosecant is r over y, secant, r over x, and the cotangent is x over y. And if you're like, well, wait, what is r again? R is the radius of the circle.
Of the circle inside of the circle?
No, whatever the circle is, the bigger circle.
Wait, so why did you have that smaller circle inside of it?
So I'm showing you here, just to pretend that that was our unit circle.
Alright.
And I'm showing you, you've got a circle that's bigger than the unit circle now. How big? R big.
Is this going to be on our test this week?
Yeah. So, let's pretend that R was 1. Okay, don't erase what you just wrote, but I'm going to erase all the R's and change them to 1s. Because that's what we did on Monday, right? And Tuesday. R was always a 1. So let's make that a 1. Let's make that a 1. 1 and 1. If I make all the R's 1, what did I just get? Yeah. I just got all the original formulas that I gave you on Monday, right? So the formulas that I gave you on Monday were really these formulas. Let me put it back the way it was. Like that, except I said to make it easier to start, I'm always going to let r equal 1. I'm not going to let r be anything other than 1 for now, till people get the hang of using the coordinates and that. Now you can see r could actually be any number. 1 is the easiest number, and most of the questions are going to be r equals 1. You'll know if r is not 1. Okay. How will you know? Well, when r is 1, the coordinates are always root 2 over 2, 1/2, and root 3 over 2. If you get a coordinate that doesn't look like any of those, like here's the coordinate 5, 12. That's not a coordinate that has ever come up before. It's not a half, it's not a root 3 over 2, it's not a root 2 over 2. I know that this is not on the unit circle. Okay, it's way too big to be on the unit circle. Yeah.
So for like the bottom two, you can just use a normal y next.
Yeah, the r's just cancel themselves out. Yep. And if you're still not sure, well, why is 512 not on the unit circle? Let's graph it. So if I graph the point 512, let's see if it's on a circle with a radius of 1. So circle of radius 1 is right there. Okay, let me graph the point 512. So 5, that's 10. 512 is up there. Is that point on the edge of the circle? No. It's on a much bigger, in fact I can't even fit it on the screen completely. It's on a much, much, much bigger circle. It's not on the unit circle. Okay? So if you see a number here that's not a half, not a root 3 over 2, not a root 2 over 2. You're on a bigger circle than the unit circle. So let's see if we can find just the sine, cosine, and the tangent of that point. Okay, the one nice thing is when you have this, they always give you the point. You never have to find it. So you know how we just did problems like that, and you had to find the coordinate? When you're working with a point that's not on the unit circle, they always give it to you. You never have to find it. So what's my x value? 5. What's my y value? 12. So I have the x, I have the y, I'm missing one letter.
R.
I'm missing r. Well, 5, 12, I'm just estimating, would look roughly like that. So right 5, up 12. I need to find the radius. How can I get the radius of this circle? Yeah.
You do 5 squared plus 12 squared, and it equals radius.
What's that?
Squared.
What you just said?
I'm not doing names.
Pythagorean theorem.
Yeah. All you have to do to find the radius of the circle is use the Pythagorean theorem. 5 squared plus 12 squared equals r squared. We know it's not 1. Okay, we're on a circle that's a lot bigger than that. How big? Well, we're about to find out. 5 squared is 25. 12 squared is 144. If you add 25 and 144, you get 169. And then what would be the square root of 169?
13.
13. Now you've got r, you already had x, and you already had y. That's the only extra step when it's a coordinate not on the unit circle. You have to find r yourself. Other than that, everything else is exactly the same. Okay, so now we go back up. Sine is y over r. So 12 over 13. Okay, what was cosine? Yep. So it's x over r, which is 5 over 13. And tangent? What was that one? Yep, Joe?
12 over 5.
Yep. Same as it always was, 12 over 5. And that's it. Those are your 3 answers.
Would you simplify that?
If it reduced, yeah, like if you had 12 over 6, yeah, you'd reduce it to 2. Nope. If it doesn't reduce evenly, none of them do here, you just leave it. How come I didn't divide by r when we were on the unit circle? Yeah?
The r equals 1.
R was always 1. What's the point of dividing by 1? That's why sine, we didn't say it was y over 1. That's just y. Okay? So you didn't need to divide by r because it was a 1. If it's not a 1, that's when you have to divide by it. And you figure out if it's not a 1 using what Joe told us, Pythagorean theorem. Yeah.
What if the numbers was like 24, 12, and 6? Could you simplify the whole circle itself? That was your ending numbers. Like, if you find out r was 24, and then the other two were like 12 and then 6, could you simplify it by 6 in total? Or no?
If that happened, you could. I don't think that won't happen with any of the problems I give you. Yeah. Yeah. The x I'll always give you. If it's this kind of problem, the y I'll always give you. You just have to use Pythagorean theorem to get r, and then fill it in. Any questions on that? Okay, so let's look at this.
So wait, you said we're always gonna get the what's it called?
The coordinate?
Yeah, the coordinate.
Yeah, in that kind of problem, you would always be given the coordinate. You would never have to find it.
Can we do another one of those?
Sure, I can make one up. The last thing is just using the calculator. It's very easy. I can try to make up another one. What numbers did I use here? 5, 12, and 13? Yep. So let's try. All right, let's say you had the point. All right, so I'll write it out the way it would be written. So the point 3, 4 represents an angle on a circle. So somebody drew a circle, they put a dot, and they said, here's the location of the dot, 3, 4. If you want to see it, that's actually one that's small enough, I can graph it. 3, 4. Right there. Okay, so somebody put a circle and said, that point right there has coordinates 3, 4. It represents an angle. What angle? I don't know. It's not really a 45. That's not right in the middle. It doesn't matter what the angle is. Okay? All you need to know is it's right there. All right. So I've got the x. I've got the y. What's the letter that I need to find in order to do... We'll do the sine, the cosine, and the tangent again. Corey?
You need to find R.
Yeah, I need to find r. So r is what I just drew right there. Okay. Make your triangle. 3 and 4. Okay, how do we get r? Yeah?
Isn't it 5? But
It will be.
Yeah, because it's perfect. But you would multiply 3. No, you would do 3 squared plus 4 squared equals r squared.
Yep. That's why I picked the 3 and the 4. So we've got 9 plus 16. So the square of the radius is 25. So what's the radius? 5. So I've got r, x, and y. Right. So sine is normally y, but if you're on a circle that's not the unit circle, just think in your head, divide everything by r. Divide everything by r. So sine is normally the y, but I have to divide it by r. Cosine is normally the x, but I have to divide it by r. And then tangent, we saw the r doesn't make a difference, it cancels out, so tangent is the same. So what would tangent be? 4 over 3. Okay, so it's really very, very similar. Just think in your head. Once you write it down, remember, divide it by r.
Yeah, there's no reference C on the test, right?
Not for this one, nope.
No, I remember it.
So what you have to remember is the 3 coordinates, right? Or the 2, 1/2 root 3 over 2, and root 2 over 2. So you got to know those coordinates, and then the formulas. Y, x, y over x. And then when you flip them, 1 over y, 1 over x, x over y. And if you had a problem like this, not on the unit circle, I just think to myself, oh yeah, take my formulas, divide by r. Divide everything by r.
Test like this?
There wouldn't be a lot of these, but maybe one, probably like 10 or 12 of the other type, and maybe 1 or 2 of this type. Okay, so if you're working with an angle that's not a multiple of 30, it's not a multiple of 45, we don't have a way to sketch that on the circle and find a coordinate. So basically you just use a calculator. Alright, so if you're using a calculator, first thing you have to check when you look at the problem, is it in degrees, like this one, or, well, that's also degrees, or is it in radians, like that one? How do I know that 2.4 is radians? What's there or what's not there that tells me?
Degree symbol.
The degree symbol's missing. If the degree symbol's missing, that's not a mistake. That means it's in radians.
Does it matter what we put after, like, the sine and cosine and stuff? Like, you know how you had that little, like, whatever you said, like, Greek symbol or whatever after it? Like, What? Theta?
Oh, the theta?
Yeah, like, does it matter? Because, like, you know how it would be like, you put, like, sine and then the theta and then equals?
This is the theta in this case. Theta is your angle, and I'm telling you that
Yeah, like,
theta is 18.
If we were to put, like, sine equals and then the answer, would we, like, get marked off since we didn't have something like...
No, that's okay.
Alright.
Yeah, that's fine. Alright, so to find the sine of 18, first thing I got to do on my calculator is make sure it's in degrees. This calculator has the buttons up at the top. Degrees and radians, I just click which one I want. On the calculators that I have, there's a button at the top that says DRG. Does everyone see the DRG button at the top? If you press that, then you have three choices. Degrees, radians, and then gradients, which we don't really do anything with. You can pick whichever one you want. Okay, so you can change it in degrees to radians. Any question on how to pick the one you want from that menu? You just highlight it, or I think you can just press the number of the one you want. All right, so I'm in degrees. I'm going to do it on this calculator because it's more similar to how you have to type it in. So let me switch to degrees. And you type sine 18, close the parenthesis, and then hit enter. Okay, and if you've got 0.309, then you did it right. Okay. Anybody that didn't get 0.309?
Wait. Do it like, I
Yep.
don't know.
So you press sine.
Yeah, but
18.
when I press sine, nothing pops up. It just blinks.
Okay, well, let me show you something else. So on mine, I have to do it. See, I'm back in radians. I must have accidentally switched it again. So keep it in degrees and type sine of 18. If anybody got negative 0.75, you didn't type it in wrong. You were in radians instead of degrees.
So if you didn't have it in degrees, would it come out wrong?
Oh yeah. Yep. Yeah, you get completely around two totally different answers. Yep. Now, on this calculator, I have to type it in backwards. Okay? I like the graphing one because it's like the ones you guys have. You pretty much type it in the order you read it. You press sine, you press 1, you press 8.
Oh, I gotta press my sine after.
Well, on this one, I have to press 18 first and then go back and press sine.
Yeah, that's what I had to do with my phone.
Yeah. So you get the same thing.
Yeah.
It's just you have to type it in backwards from the way you read it. Okay. If anybody that has that problem, it's not a problem, it's just the way the calculator works. You could always use one of mine.
Yeah. How do you put it in degrees?
Okay, let's try this one. 356. Is that a multiple of 30?
No.
No. You're not going to do 30 times anything and get 356. How about 45?
No.
I thought we just type it right into the calculator.
Well, and what I'm doing is I'm kind of going through the thought process in my head. I'd say, okay, is this a problem I should be drawing a circle for, or is this a problem I should type into the calculator? So when you're given an angle, like if I said to you 120, is that a problem you type it into the calculator, or is 120 a problem you're drawing a circle for?
Sure.
Right. And the way you figure it out is you say, okay, 120 is a multiple of 30. He showed us how to do that on the circle. 356 is not a multiple of 30. He said to plug it into the calculator. So you have to know, okay, calculator problem, or is it one where I draw it out? Yeah.
Couldn't you just think of it as, if it has a 0 or a 5 behind it, you might be able to do it?
Yeah, but would you be able to do 70 the way I showed you? No. So that ends in
I
a 0.
said if it, you just, like if it doesn't have a 5 or a 0, don't even like think about doing that.
Yeah, if it's got random numbers like 356, it's, yeah, we use the calculator.
Wait, so that's all we do for those problems?
Yep.
Wait, if you did not know how to change it into like on your calculator into degrees, could you just change that into radians?
You can. The only danger is if you make a mistake doing that, now you're doing more work, so there's more chances to make a mistake.
Yeah.
But absolutely, you could change 356 degrees into radians and then do it in radians.
Yeah.
But that's extra work. I like to just change the mode on the calculator to whatever the problem is asking. So, in this case, it's 0.998. How many people got .998.
No.
No?
Yep.
You got it?
Wait, I might, hold on.
So for yours, remember you gotta type it backwards. 3, 5,
I
6.
think I might have pressed this. I don't know.
Cosine.
Yeah, I got it.
You got it? Okay. So now, let's look at this one. Tangent 2.4. Now, as Justin said, you got an option here. That's in radians. If your calculator didn't do radians, you could change it to degrees by hand. You learn how to do that, and then do it. But my calculator does radians, and all the ones that I give you do radians. So change it to radians, and then just type it in. Tangent 2.4. Did anyone get negative 0.916? Yep. If you got that, you're doing it right. Okay. Any questions on how to do sine, cosine, and tangent? All right. Cosecant. So let's look at the calculator. And is there a button on the calculator that says CSC? Not this stuff with a -1 above it. That's something else. We're not going to do that this week. But is there a button on there that says CSC? No. Same with this one. I have sine, I have cosine, I have tangent. I don't have a button that says CSC. So if we want to get CSC, let's go back to this problem. We could get the sine first, and then what did we do with it to get the cosecant? We flipped it. That's how you have to do it. So let's go back to the problem. Back here. So they're asking for the cosecant. Well, I don't have a button for that. But what I can do is take the sine and flip it. So take one, just put it in the bottom of a fraction. So that's how you find
Under
cosecant.
degrees or radians.
Which one should this be? Degrees or radians? Should be degrees. So I look at my calculator, whoops. My calculator says I'm in radians. So if I type it in like that, I'll get an answer, but it's not right.
Wait, what did you hit after? Like, what would you hit? The sine.
At this point now, you just hit enter. But I wanted to change my calculator to degrees first. So if you got negative
Wait, why'd you press
1.086,
sin?
you did it correct.
Why'd you press sin?
Because it's cosine.
Why did we press sine?
Because you had to flip the sine.
Because I got to flip it. There is no button for CSC on the calculator. You can look for it. You'll never find it. The only way to get cosecant is to flip the sine. Okay. Was it negative 1.086? It was, yep. Let's try another one. Secant. Is there a button on here for secant?
No.
No. So, what does that mean? We're stuck? We just can't do it?
You gotta flip the cosecant, or the cosine.
The cosine. Right? We learned that if you take the cosine and you flip it, that gives you the secant. That's the only way to use the calculator to get what they're asking. Take the cosine and flip it. But that's not going to be the right answer.
That's in radians.
Because I'm in degrees, this problem went back to radians. So you should get 1.041.
I did not get that.
All right, and did you put your calculator in radians?
Yeah.
And you typed 1 divided by cosine 6? Let me take a look. Nope, you did 1 times cosine 6. You gotta make sure you get the divided symbol in there. Yeah.
I don't know how to get my calculator in the rate.
So to get that, it's the same as this one. You press mode, and then you'll have a choice between radians and degrees. You see it? On a graphing calculator, it's a little different. And that's what you got. Did you get that now, sir? Yep. Okay, let's try one more. Cotangent of 13 degrees. Before I even type it in, what should I do on my calculator this time?
Change it to degrees.
So let's go back to degrees. And now I'm looking for the COT button. Am I going to find it? No, so I got to figure out a different way to use this to get the answer. How can I get cotangent using my calculator? Yeah.
1 divided by tangent.
Exactly. You flip the tangent, you get the cotangent. So 1 divided by tangent, 13. Okay, 1 divided by, remember that just flips it. And you get 4.331. How many people got 4.331 for that? Yep. So most people get the sine, the cosine, and the tangent. On the test where I see the most mistakes is these three. Okay? If you're using a calculator where you have to type it in backwards, that's a little tricky. I would probably stick with one of mine for the day of the test.
I just typed this in backwards like 4 times and it keeps coming up like 0.230.
Yeah, it's a little tricky to type in backwards. I can show you, but you're probably better off to use one of mine. It'll probably be easier.
No, that's the only one that didn't work.
That's the only one? Okay.
That's the easiest.
So the homework tonight on page 116, it's 49 to 57 odd, 67 to 81 all, so you need a calculator for every one of those, and then 83 and 84. Okay, so we'll go over the homework tomorrow. We'll do a review, kind of working in groups, practice for the test, and then we'll have our test on Friday. Just a reminder that progress reports close Friday, so, well, technically they close during your shock week, but this week is the last week I see you before they close.